Okay, we're going to start looking at 8.2. So this is the transition matrices and recurrence relations. So a little bit of this takes from the finance unit where we were building recurrence relations, which is how we find the next part in our sequence. So recurrence relations won't take us directly to a point in time. Instead, they will help us to find or be the formula that helps us to find the next value in our sequence. So the power of transition matrices is they can be used to help make predictions. So for example here, we've got an industry that has 1,640 people that transition between casual and permanent employment from year to year, according to this matrix. So remember, this year at the top, next year on the right-hand side. This matrix states that if they're in casual employment this year, 80% will be in casual employment next year. If they're in casual employment this year, 20% will be in permanent employment next year. Remember that our columns need to sum to 1. We take that percentage that we might be given in a question and we turn it into a decimal to place into our transition matrix. So how do we actually use that information without having to do hand calculations for each part? What we actually need is our state matrix. So this is the matrix that tells us how many people we have in this industry and where they started this year so that we can see where they moved to by multiplying it by our transition matrix. So our state matrix here, S0, so this is our starting, this is where they started, this is the first iteration. So they started with 1,200 in casual employment and 440 in permanent employment. So if we have our transition matrix and we multiply it by our state matrix, we actually then find what next year will look like, where those people will sit in casual versus permanent employment. We call this S1. So that is after 1 year. So S1 is our transition matrix multiplied by our state matrix, which will give us how many people will be in casual employment and how many people will be in permanent employment after the first year. We can then do the same thing. We take our transition matrix, which stays the same. So the transition matrix doesn't actually change, but instead of multiplying it by our state matrix, we're going to multiply it by, like our initial state matrix, we're going to multiply it by our S1. So where they were sitting in that next year to then calculate the year after. So that would be after so we've got our initial, we've got our first year here, and then we go to our second year here. All right. The sum of those two values, so 1,200, 440, 1,004, 636, 867, and 773 will remain the same. We're not losing any people out of this industry. We're not gaining anyone extra in this industry. Something to think about too is when we're doing matrices like this, what is it that we're working with? So in this instance, we're working with people. So it's appropriate to round to the nearest whole number. We can't have half a person in a job sitting between casual and permanent in this instance. So just always go back to what is a reasonable answer. Is it appropriate to round in this case? Is it not? What am I rounding to? Because it will not state it in the question. It is assuming that you are going to know whole people. We need to have whole numbers. Okay, so to actually write this out in terms of a recurrence relation would look like this. So we have our S0 equals, and we put our initial state matrix there, comma, Sn plus 1. So Sn plus 1 is the next number in our sequence is equal to our transition matrix T multiplied by Sn, which is the previous number in our sequence. Okay, so let me say that again. So our S0, so our initial state matrix, our starting value is this, comma, the next number in our sequence is equal to the transition matrix multiplied by the previous matrix. Okay, Now, remember, recurrence relation, 2 parts. So recurrence relation, 2 parts. You always have to have that initial state, comma, how you find the next number in the sequence. Please keep that in your mind, that a recurrence relation is different. It's the next number in the sequence. Okay, so this goes back to that finance part when we were writing recurrence relations. There has to be 2 parts, your initial state and then how you find the next number in your sequence. Please understand what this subtext means, so that n plus 1, the next value in your sequence, is equal to transition multiplied by that number that you already have. Okay, this needs to be in your notes and you need to have an example of how to use it. Okay, you need to remember too that the transition matrix has to be on the left-hand side for this. So it is T times Sn. You can't flip them. It isn't, multiplication in matrices, remember, isn't the same as our traditional multiplication. We can't just be flipping and swapping. Order matters. Okay. I'm going to skip over that for a little bit and let you go through them. I'm just going to go through the content first. So then the state matrix rule. So recurrence relation has 2 parts. It finds the next number in the sequence. The state matrix rule will take us directly to a point in time. So if we wanted to know after 50 weeks, how many people will we have in casual employment and how many people will we have in permanent, we use the matrix rule. The rule differs to the recurrence relation. Recurrence relation, 2 parts. State matrix rule, point in time. Okay. We are going to use our calculator for this. We're not going to be required to do it by hand, but you need to understand what the rule is and how to use it appropriately. Okay, so the initial state is still S0 where they started. So after one transition, that would be S of 1. So after one transition is S of 1 equals the transition matrix times that previous value. Okay, so after 2, we know that we've got this. So this is using that recurrence relation. How do we do it? So then after n transitions, what we're actually doing, so when we go down and break this down, we can simplify it to say that to find the S of n, so say we wanted to find the S, so the number of people in each employment type after 50 weeks, so that would be S50, so at 50 weeks is equal to our transition matrix raised to the power of, and in this case it would be 50. See how the n's are both n, they have to be the same. So anytime you're working in an equation and you've got a variable, say it's n has to be the same when it's working within that one equation, multiplied by your initial state matrix. Okay, so again, very important formula, but you have to understand the difference between the recurrence relation, 2 parts, you are finding the next number in the sequence, and the state matrix rule, which is finding a point in time. Okay, have that in there. For this in your calculator, you are simply going to save your matrix in to your CAS. You then take that value, say if you've called it A, you would go A to the power of how many weeks you're trying to find. In this instance, we're going 6 weeks. So A to the power of 6 multiplied by that initial state. Okay, so you would save both of those elements in there, being your transition and then your initial state, to reuse them in your calculations. Again, remember, go back to the question, what variable are we talking about? In this instance, we're talking about people. So how many motorists? We need to use whole numbers. You can show in your working that you've done a decimal, and then in your final answer show the rounding component of that. In case you make a rounding error, I would recommend putting as it comes out of your calculator and then showing the rounding. Remember to use that approximation symbol if that's appropriate. And again, some worked examples. Okay, I'm going to leave it there. I want you guys to take yourselves through the worked examples and see how you go for transition matrices and recurrence relations. I'm gonna make a video to go through some of the SAC parts. I know that lots of you have emailed them through, which is great. I will send you some feedback on those. I'm also going to make a video for the next part being transition matrices and long-term trends, which I'll upload for you to watch.